Hello guys, welcome back to my channel Data Science with Gagan. So in today's video we will take up other computer vision project where we will see other aspects of YOLOv11 model like segmentation, post detection, oriented detection and classification. As in the last video we performed object detection using YOLOv11 model, but in this video we will see how can we do all of these things: segmentation, post detection, oriented detection and classification. So first we will see how can we do all of these things in the image, and we will see what output we get from the model in the result, and later on we will see how can we do all of these things in the live video. Okay, so let's start with the segmentation. So segmentation means dividing an image into a multiple regions. So that's what I have mentioned here. Segmentation is a fundamental task in computer vision which involves dividing an image into its constituent parts or objects, and the goal is to simplify the image into meaningful regions which makes it easier to analyze and understand. As segmentation is of multiple types, and some of them I have mentioned here, which are semantic segmentations and instance segmentation. Now what is semantic segmentation? uh, these are the segmentations which assigns a class level to each pixel in the image, like car, tree, person. And for semantic segmentation, we have a real-time use case of self-driving car, which uses semantic segmentation to identify roads, pedestrian, and other obstacles. And now, what is instance segmentation? These are the segmentations which identifies and separate individual objects of the same class. Let's say an example: if I have a class car, right? So it will classify all the cars into its categories, like car A, car B, car C. Okay, so that's what instance segmentation does. And I have also mentioned one real-time use case of autonomous drone, which uses instance segmentation to detect and track individual objects. And the one more thing which is a note over here, that YOLOv11 performs instance segmentation. So the model is able to classify a car into a multiple class. If it is saying this is a car, then it will say this is a sports car, this is a normal car. Okay, so using instance segmentation, YOLOv11 can do this thing. So now let's have a look how can we use YOLOv11 model in the YOLOv11 for segmentation in Python. So here you can see this is a code. First, I am importing all the necessary libraries, and as for the object detections, we have multiple versions of the model which were in the range of from nano to Excel. So similarly, we have for all these things from N to Excel. So here you can see I'm using the small model for segmentation, and this is the image. So let's see what it returns in the result for this particular image if we run the segmentation on this. So to show the results, I'm using this function show. So let's see what it returns. So here you can see, right, it has created some segmentations, or it has created some mask for all the objects that it can detect in the image. Like for bus, it is saying this is bus, and it also created the mask for the bus. And similarly, it has done for the persons, right? Now let's see. Now let's run it on the other image. So I have downloaded one image of cars. Let's see whether it can identify the car or not. So here you can see, like with good confidence score, it is able to identify all the cars, and also it is able to identify the mask in the correct way for all four cars here, right? So now let's see what it returns in the results. So here in the screen you can see, right, it has been that segmentation pre-trained model has been trained on 80 classes, right? And then in the boxes details, it returns all the bounding box details: xy xy xywh xywhn xyxyn, right? And then in the mask, it has written all the mask for all the objects that we saw, right, in the image. So now let's start with the pose. So second thing is pose. So pose means to identify the specific region of the image or specific points on the image, right? So that's what I have mentioned here, that about the pose estimation, that it is a task which involves identifying the location of specific points in an image, usually referred to as key points. The key points can represent various parts of the object such as joints, landmarks, or other features. The locations of key points are usually represented as a set of 2D, which is XY, or 3D, which are X, Y, and visible coordinates. Okay. The output of the pose estimation model is a set of points that represents the key points of an on an object in the image, usually along with the confidence score for each point. And the pose estimation is a good choice when you need to identify a specific part of an object in a scene and their location in relation to each other. So this is all about the pose. Now let's have a look how can we identify pose, how can we detect pose using the pose model. So as you can see here, I am loading this model, and now how using this model I am detecting the pose in this image. Now once I'll get the result, I can show it using the show function. So that's what you can see on the screen, right? It is detecting all the key points of the person. So we have three persons right here. So for all of these person, it is detecting the key points. So here you can see, right, that on the knee, on the elbow, wherever we are having the joints, for all those joints, it is detecting the key points, right? So now let's see what it returns in the results. So basically it is trained on the person class. That's what you can see here. And in the box details, it returns all the bounding box details like xw, xywh, as similar to the previous one. And in the key points, it returns all the key points as I told above, right? With the confidence score for each point it returns. So that's what it is returning here, all the key points with the confidence score. So this is all about the pose detection. Now let's have a look at the third aspect, which is oriented detection. So oriented detection is same as object detection, but it is the next step of object detection, as we have rotated bounding boxes in oriented detection, whereas we have fixed 90-degree or 180-degree angled bounding boxes in object detection. And that's what you can see on the screen. Oriented object detection goes a step further than object detection and introduce an extra angle to locate objects more accurate in an image. And the output of an oriented object detector is a set of rotated bounding boxes that exactly enclose the objects in an image. Okay. And it includes confidence score and class level for each boxes. And the object detection is a good choice when you need to identify object of interest in a scene but don't need to know exactly where the object is or its exact shape. Okay, so this is the oriented detection. Now let's see how can we do it in Python using YOLO. So in the 33 cell you can see I'm loading this model for oriented detection. Okay, so let's load it. Now let's see what result we get from the orient model when we run it on the image. So, so using the show function again, we will see the output. So here you can see, right, we have a rotated bounding box which represents the exact position of all the objects, right? So this is that's what oriented detection does. And now let's see what we get in the output, in the result. So here you can see, here we have total 15 class on which it is trained, which is plane, shape, right? And now let's see what it returns in the OBP. So here you can see, right, this is all where we have all the information related to oriented boxes, bounding boxes, right? So this is all comes under the oriented detection. So now let's have a look at the fourth aspect of YOLOv11 model, which is classification. So classification means to classify an image based on its content. If image contains any animal, so we will classify that image with the animal name which is there in the image. If image contains car, then we will classify that image as car. Okay, so this is the classification. So basically it is a fundamental task in the field of computer vision and artificial intelligence, where the goal is to assign a label or category to an image based on its visual content, as I told. And this process involves analyzing pixel data in the image using algorithm to identify and categorize objects, scenes, or activities present within it. Okay, so this is all about the classification. So now let's have a look how can we do it using Python and YOLOv11 model. So first we will have to load this model. So as you can see here, I am loading out the model from the hub, and then once we will load this model, we can run it on the image that we want. Okay, so I am loading so I have run this model on the bus image. So basically it should return bus as a class. So let's see what it returns. So yes, so here you can see it is classifying this image as mini bus with 52% confidence score, and also you can see it is giving other classes as well, but with the lower confidence score. So that's why we are saying this is as a mini bus. Okay, so let's run it on the other image of cars. In this image we have four cars, right? So let's visualize the result. So here, yes, so here you can see basically we have all the cars as sports car, right? So that's what it is returning in the image as sports car with 93% confidence score. Okay, let's close it and let's see what it returns in the names. Okay, so here you can see it is trained on almost 1,000 categories, right? Which is huge. Okay, so this is all about the classification. But then now the question is, can we do it all these things in the live video? Because we have run all the models and we have done everything on the images, right? But and the answer is yes, we can do it in the live video as well. So let's see how can we do it. So first we will start with the segmentation model. And okay, let me do it. So here the thing is, right, what parameter we will have to give or we should give while calling up that model, right? So here you can see I'm giving 0, and 0 means I want to run this model on live feed. If I want to run this model on any image, so we will have to give the path to that particular image. If I want to run this model on any stored or recorded video, so I will have to give that path to that particular video. But I want to run this model on live video, that's why I'm giving 0. Show means I want to visualize all the result that I am getting from the model. So let's run it. So yes, here you can see it's the visualization that we are getting from the model. Okay, let's run it on the bottle. Okay, let's run it on the cup. Yes, it's giving quite good results. Okay, now let's try out other models as well. Okay. Okay, so now what we will do, I'll directly switch to classification model because I don't have any particular object for the oriented one. But what I'll do, I'll find some images or find some video where I can find some objects which are there in the video at different angles, right? So then we will run the oriented model, and for the post model what I'll do, I'll stand and I'll show how it detects the key point. Okay, so directly let's run the classification model and see what it returns. Okay, so here if I show this bottle, what it returns, okay, so it is saying shaker, okay, with some confidence score. If I remove this, then it is detecting so many things in the image, and based on those details it is classifying this frame with iron. Okay, let's close this, and now let's have a look at other models output. Okay, so this is all about the YOLOv11 4 aspects, where we saw uh, what results we get if we do all the things using a YOLOv11 model, and we saw the results and it was quite good, right? So let's see you in the next video, where we will see some other projects apart from the computer vision projects. Okay, let's do one thing. What we can do, I'll take up some LLM model or Gen AI model for object detection, and let's see what if we use LLM model instead of object detection model, and we'll see what results we get from that model. Okay, it will be quite amazing, right? So let's see in the next video. We will take up that project where we will be using LLM or Gen AI to identify the objects in the image or video, and we'll try to do it. Okay, so yeah, see you guys in the next video. Bye.
To keep me motivated for more videos on data science projects, please do like and subscribe. And please do not forget to press bell icon for notification of new projects videos.